What is hardness? Hardness is the resistance of a material to be indented or compressed a short distance. All materials have a hardness. For example, marshmallows are very soft and easy to compress. Tennis balls, which have soft elasticity, are more difficult to compress. And golf balls, which are considered hard, are very challenging to compress. In industrial applications, hardness is a common value to measure and define a material's properties. This video explains the various methods to measure a material's hardness and how those values apply in technical applications. Hardness is particularly important for compression gaskets and seals. Hard materials withstand high pressures with minimal distortion. Soft materials deform at low pressures, allowing use of thinner constructions with less clamping pressure and in applications with greater variances in bond line thickness. Hardness will be a determining factor in choosing a gasketing material depending on customer application requirements. The most common way to measure hardness is with a durometer gauge, giving what is called a durometer hardness. While there are several different formats, the most common are Shore and Asker, named after their inventors. Both use indenters connected to a dial gauge via a spring, and are using the compression of the spring to give a durometer hardness reading. We'll focus on Shore durometer gauges. There are 4 ranges of hardness on the Shore scale. 000 is for very soft materials. However, it is rarely used in industrial measurement. Shore 00 is used for soft rubbers. Shore A for soft to medium hard rubbers, and Shore D for very hard rubbers and plastics. All silicone products, with the exception of soft gels, can be measured in the ranges just discussed. To get a uniform and reproducible measurement, samples must be flat, free of voids and bubbles, and be at least 1/4 inch or 6 millimeters thick. It is best to use one solid sample, but thinner flat pieces can be stacked to reach this standard thickness. The Shore scale ranges are accurate for readings between 15 and 85. Outside of those ranges, it is best to use the next higher or lower scale. For some products, the technical data sheet may show values from more than one scale. Using a Shore durometer is a great way to measure hardness in soft to very hard products. As noted earlier, soft silicone gels are too soft to be measured with Shore durometers. There are 2 alternative methods to measure gel hardness. The first method uses a penetrometer to measure the distance a pointed weight will compress or sink into a sample. The higher the value, the greater distance the probe penetrated and the softer the gel is. The second method uses a texture analyzer to push a probe into the material and measure the force of resistance in grams. The lower the measured force value, the softer the gel is. Another common metric for a material's resistance to deformation that is not discussed in detail is Young's modulus. In general, Young's modulus can be correlated with gel and Shore hardness as shown in the graph. When looking at hardness values on technical data sheets, it is important to note that durometer test results can range, depending on the test method and batch reproducibility. Generally, this is a plus or minus 5 points for Shore A or D, and plus or minus 15 points for Shore 00 and 000. This is important to keep in mind if the material's hardness is on the edge of customer requirements. Hardness is the resistance of a material to be indented or compressed a short distance. All materials have a hardness, and hardness is a common value to measure and define a material's properties. Typical measurement methods include utilization of Shore durometers, penetrometers, and texture analyzers. A material's hardness is an important property when selecting the right silicone for a customer application.